Hello everyone, welcome back to this video tutorial series on D04 Microcontroller based System Design Lab course. In this session, we are going to interface Multiplexed 7 Segment Display with PKTNF4520. But before writing code, we will just see the schematic of this interface. So as you can see in this schematic, there are 4 7 segment displays are present over here. And the data pins of all these 4 7 segment displays are connected to the PKTNF4520. So as you can see over here, from RD0 to RD7 are connected to this PKTNF4520. And there are 4 control pins. So control number 1, which is called as SSD3, SSD2, SSD1 and SSD0. So this SSD0 is for LSB display, SSD1 is for this display, SSD2 is for this display and SSD3 is for MSB display. So now over here you can able to see all the data pins of 4 7 segment displays are connected to the port D of PKTNF4520. Now it is a common cathode 7 segment display. So we will just see how we can able to interface this multiplex 7 segment display with PKTNF4520. So we can go back to our MPLABX IDE, and over here we are going to create one project. So click on next and select your device PKTNF4520 microcontroller. Click on next, select the X8 as compiler and click on next and provide the name, let's say multiplexed SSD, and click on finish. Now we need to create the source file. Just right click onto the source file and under new select main.c and click on this finish. First of all, we need to configure the bits of PKTNF4520. So go to production, set configuration bits, and over here we will select the oscillator, which is HSPLL. We will turn off all the other things which do not require. So we are just turning it off and click on generate source code to output. So you just copy this one and paste inside your .c file. So I'll just select this and we have just pasted over here. Now first of all, we will define the frequency of your microcontroller by using xtal_freq macro. So the frequency will be 40 megahertz. Now we are using common cathode 7 segment displays. So we will use the array for common cathode in our previous example as we have written over here. So we will I'll just copy it and paste it over here. Now you can able to see over here the 7 segment displays are connected to port D and the control signals are connected to the port A. So we will just configure those ports as a output. So trace D whole port as output and trace A is equals to 0x00. Initially we will write lat D is equals to 0x00. So the default value for all the bits are 00. Same for port A, 0x00. Now inside while one we need to write our code. So suppose, let's say if you want to print 6537, so this is the number that you want to print onto the multiplex 7 segment display. So how are you gonna do that? So first of all, you need to find the position of each number. Okay, so for that we will just do some mathematics. So suppose we are having 6537 is the number, and we want to find the fourth position, or let's say 1000 position, whatever the digit which is present at 1000 position. So what we will do is we will just use calculator over here. So if you take that number 6537 and divide it by 1000, you will get the 1000th position number, which is nothing but the 6. So over here, let's say 6537 divided by 1000. So the result of this expression is 6. And if you want to display this 6 digit onto the 7 segment display, you need to use common cathode array. Inside that we have stored the hex code related to each digit. So we will just use the array, which is CC, and this expression. So 6537 divided by 1000, and we will assign the value of this array to port D. LATD is equals to CC of 6537 divided by 1000, which is nothing but the 6. So over here, as you can able to see, we have some control signals over here to turn on the particular display. And if you want to print this 6 number onto the MSP display, we are going to use RA3 pin. So again, come back to the code. So we can write LATA bits dot LA3 equals to 1. So we are just turning on the particular display. We will provide some delay underscore ms, let's say 1 millisecond, and again we are going to turn it off. So bits dot LA3 equals to 0. So we will just simulate this one. So we are going to compile it initially. I'm going to see whether there are any issues with the code or not. So it is successfully compiled. Now we will import the hex file. So this is our hex file. So click OK and run. So now you can able to see 6 number is printed onto this multiplex 7 segment display. Same way you can able to find the position number from this 6537. So suppose you want to find the position of 1000 position, you need to use an expression like this. So the number which is 6537 divided by 100, and if you take the mod of this by 10, you will get the third number over here, which is nothing but the 5. But instead of writing like this, what we will do is we will define one function. So over here we will declare the function. So let's say void SSD display. It will take some number, so int number, and now we are going to define this. And this code we are going to write inside the function. and the number can be anything. So in our example it is 6537. So we will just call the function ssd display, and inside that we can send this number, and over here we will write number as the variable. Now we will use this formula for getting the third position, which is nothing but the 100th position. So over here we will write in comment, which is 1000 position. Now over here we are going to use LATD equals to CC of, in bracket, the number divided by 100 and mod of 10. Now we are supposed to turn on the second display, which is this one, and for that we need to use pin number 2 of port A. So again over here, so we will turn on the port A, pin number 2nd. So LATA bits dot LA2 equals to 1. We will provide the delay of, let's say, 1 millisecond, and again we are going to turn it off, equals to 0. We will just compile this and let's see whether we can able to display the number 6 and 5 onto your 7 segment display or not. So as you can see, we are able to display 6 and 5 onto our multiplex 7 segment display. Now we will go for the second position, which is nothing but the 10th position. So over here we will call it as 100th position. For that we need to again use one mathematical formula. So again, let's say the number is 6537 divided by 10, and if you take a mod of it, so mod of 10, you can able to see we are getting the second position number, which is nothing but the 3. So we will use the same formula that we have using over here. So lat d is equals to CC of number divided by 10 and mod of 10. Now we need to turn on this third display, and the pin for this is, which is RA1. So we are going to turn on the display. So LATA bits dot LA1 equals to 1. We will provide some delay, and again we turn it off. So LA1 equals to 0. We'll just compile this. Now we will just simulate the circuit. Now you can able to see 6, 5 and 3 is printed onto the multiplex 7 segment display. Now we will go for the fourth digit, which is the LSB digit, or ones position digit. So again go to the calculator, So the value is 6537 divided by 10, and mod of 10 is for second position, whereas for first position or ones position is 6537 mod of 10. And you can able to see we are getting answer as 7. So we will use this formula. So LATD is equals to CC of number and mod of 10. And again the control signal for this LSB is RA0. So LATA bits dot LA0 equals to 1. Again we will provide some delay, let's say 1 millisecond, and we will just turn it off. Dot LA0 equals to 0. So we will just compile the code. And if you go to the simulation, now you can able to see we are able to print the whole number, which is 6537. Now instead of this number, you can also able to send any number to this function. So let's say 7345, and if you compile it again, okay, successfully compiled. Now go back to our simulation and see. So see over here, now we can able to send or print any integer number on this multiplex 7 segment display.